Hi there, this is Wasim Asghar. I'm a licensed professional engineer in US and Canada. I've authored several books on the topic of FE electrical and computer exam preparation, as well as the PE power exam preparation. I also run very popular programs for FE electrical exam prep and PE power exam prep. In this video, I will do a comprehensive overview of Section 1 General Power Engineering, Subsection B, which is applications. Section 1 and Section 4 are the two biggest sections on the PE power exam. And within section number 1, we have measurement instrumentation, applications, and codes and standards. This overview is extracted from one of the live trainings that I did for my students who are enrolled in my PE Power exam preparation program. Within my PE Power exam preparation program, I have the on-demand program, which is self-study. It contains over 150 plus lectures with detailed explanations, in-lecture practice problems, quizzes, mini exams, computer simulated practice exams. On top of that, as part of a bundle, I also have live training program in which students get real-time access to me. We work through all the exam specification topics for the PE Power exam. It also includes additional homework assignments. There's a schedule that students follow on a weekly basis, and it keeps them on track. If you're interested in learning more about my FE Electrical and Computer and the PE Power exam preparation programs, please visit my website www.studyforfe.com. Before we dive into the content, I would really appreciate it if you could like this video and click the subscribe button if you haven't already done so. Thank you. The topics that we discussed today for general power engineering, which is section number 1, applications, which is subsection of general power engineering, subsection B. This is sort of like 50% of the content: reliability, illumination, demand calculations, energy management, and engineering economics. If you want to keep things simple within reliability, the two topics that you must understand, if you look at the NCS P Power Reference Handbook, is the difference between series configuration and parallel configuration. As you know, when we are dealing even with circuit analysis, when we have a set of resistors that are connected in series, what is the overall resistance of the network of that particular branch when resistors are connected in series? It is greater than any individual component, right? That is a key characteristic of series configuration. And when you carry this over to reliability, the same concept applies. If you have multiple components that are connected in series, okay, what happens? What happens in series, guys? Is that true? Is the reliability of the overall system greater than the reliability of any individual component? No, see, it flips, right? I primed you to think in the wrong direction. You got to be careful. Okay, it is because reliability gets multiplied, resistance gets added. So when you have a series network, okay, you guys need to pay attention. If there is even a single failure, right, this input, output, whatever the process is, it's going to fail. So the formulas are given in the reference handbook. Please pay attention to them, right? When it comes to the series components, the reliability of the overall system is actually less than the individual reliability of any component. Okay, so the series configuration, the only similarity between the series configuration when it comes to reliability and series configuration of resistors, impedances, inductors, capacitors, whatever, is that they are organized in series. But as far as the overall value is concerned, reliability of the overall system arranged in series is always less than the reliability of the smallest component. Does it make sense? Okay. So I intentionally set up the scenario to lead you in a wrong direction, and that's where you have to pay attention. Okay, guys, don't just remember series, parallel from resistors. Look at the formula that is given to you in the reference handbook and apply it properly. And the opposite is true for parallel configuration because there are redundant paths. And we discuss this in a lot of detail in the on-demand content, in the lectures, in the quizzes, in the live training and whatnot. If this guy fails, you still have, if you're going from point A to point B, you still have this route, you have this route. So when it comes to the parallel configuration, the overall reliability of the system is greater than the reliability of the highest component in the system. Now, am I memorizing this? Well, for me, it's different because I teach this so frequently. Yes, at a certain level, I'm operating in an autopilot mode, right? But I always try and go back to first principles even when I'm trying to explain. Make sense? And we had a lot of discussion around MTTR, MTTF, MTBF. The best way to understand these is visually. Okay. In the lecture, I've included that visual that shows you on a timeline when the failure happens. Okay. How long it takes to fix the problem, and then how long it will basically operate before it fails again. Right. And all of that can be tied back to failure rate, availability, downtime. Another thing that you need to remember in reliability is 8760, which is the total number of hours available in a year. Clear? So these are some of the key pieces of knowledge that you should have a good handle on in reliability. And if you do, then I believe that you can easily tackle questions with great confidence and competence. Next one is illumination and lighting. Now, this is a tricky one. The reason being, the nomenclature that you see right up front in the reference handbook contains so many variables, right? So many terms, so many units of measurement, and 99% of those, at least I'll speak for myself, when I was working as a design engineer for over a decade, I actually rarely use them. In fact, I use them only in the very early phase of my career when I was a junior engineer doing a little bit of drafting, AutoCAD, and a little bit of um, lighting calculations. But then over a period of 2-3 years, lo and behold, a lot of lighting calculations softwares came up, and Lexicon and Cooper Lighting, Philips had their own Dialex, and so many different softwares. And for the most part, even if somebody has to do lighting design, it is generally not your professional engineers. It's typically electrical designers and drafters who would be doing it. So the point I'm trying to make is that the units of measurement, nomenclature, the variables that we come across in lighting are not second nature to us. Okay, we rarely get exposed to them, and that's why you have to pay more attention, not less attention. Okay, so lux versus foot candle, candela, the formula for illumination intensity. Okay, all of these are luminous flux, illumination. They all sound so similar that it can be very difficult to make distinction. Okay, so please pay special attention in the lectures. I've divided into several pieces, several parts, and I've identified multiple places where mistakes can be made, and do these practice problems in the quizzes and the study guide homework assignments. Cosine law, I've explained that in detail. Identify the perpendicular distance, the straight line distance. Okay, what is the difference between the two? Which D you are supposed to be using in the formula? Calculations. Now, lighting, if you look at the NCA sample exam, I think they have a couple of very good questions related to lighting calculations. And terminology comes into play there as well. Lumens method is by far the most commonly used method, not the point source method. The point source method, if you guys remember, it assumes one lighting source and then a target where you're calculating the illumination. In lumens method, you can have multiple lighting sources, right? Your working plane at different elevations. And that also leads us into room cavity calculations. Pretty simple, straightforward, and you should not lose any point on them. Just make sure you sketch these problems out properly, and that will help you understand these concepts even better. And outdoor lighting is very similar to the lumens method that we do for indoor lighting. Okay. Then we have demand calculations. We had good discussion on demand calculations in the on-demand course, in the live training, during the office hours. So the way that it is laid out, it takes about 1 page of real estate in the reference handbook. Okay. And when it comes to demand calculations, what we need to keep track of is the terminology. All the words, maximum demand, coincident maximum demand, connected load, total load. So you need to make a distinction between all of these factors, right? Otherwise, it is so easy to lay the landmines for you. And if you have a wishy-washy understanding, you're going to sort of, be very uncomfortable, and you'll take a hodgepodge approach in terms of solving these problems, right? Overall, as I've commented multiple times, demand calculations is one of the easier topics in the context of the PE power exam. Like there's no comparison between demand calculations. I think it would be disrespectful for fault analysis to be inserted in the same sentence as demand calculation, right? It's day and night difference, right? But the good news is that in terms of the weightage, if a question shows up from demand calculation, the weightages would be the same as fault analysis. So you should leverage these opportunities and make sure that you put money in the bank when you see these problems. And you can only do that when your concepts are crystal clear. And there are a lot of formulas, so make sure you use a summation, put the right quantities in the numerator, denominator, and so on and so forth. Energy management, less than half a page of real estate on the reference handbook, only a couple of equations related to power and energy. But we know that arguably the most difficult problem on the NCESP power sample exam, if I'm not mistaken, is problem number 22, based on the latest edition that we have, is from energy management. So these type of nuances are actually a good reminder that a super difficult question can be created from a super easy topic and vice versa, right? If you decide that, okay, power system stability, it gives me goosebumps, I'm not even going to touch power system stability or fault analysis or induction machines or synchronous machines. It's just too much. I can't handle it. Well, what if they ask you a very simple, straightforward question from a very difficult exam topic? And what if they ask you a very easy question from a difficult one and vice versa, right? So you got to make sure that you have sound fundamental understanding, and waveform analysis is the name of the game when it comes to demand calculation and energy management. If you're good with straight line equations, and we've done several practice problems, right? If you don't rely on plug and chug approach of finding the area under the curve, if you're able to divide, find the regions of operation, and go about solving it in a methodical, systematic, and proper way, then these problems are not that difficult. You just have the layer of understanding that you have to throw on top of waveform analysis is the terminology. Okay, and that's basically the issue with problem number 22 in the NCA sample exam. Okay, how do you interpret what is being asked and what is already given to you? Make sense? And the last but not the least is engineering economics. So back in the day, right, FE electrical, when we were going through, engineering economics was given a lot of respect, reverence, and honor, because engineering economics was given a title of a standalone section, right? We all had to sort of give our respects to engineering economics in section, I'm forgetting, section 4, if I'm not mistaken, section 4, I believe, right? But now engineering economics is a simple line item, right? It's a small fish in a big pond, right? But that does not mean that you should ignore it. I mean, if you've recently taken the FE electrical, just like in the last couple of months, okay, then you may not need to go as hard at engineering economics as you would if FE was way back when, okay? So as I mentioned in the FE electrical program, those of you who've taken my FE electrical program, is that if there's one thing that you need to understand about engineering economics, it's this guy. If you are able to understand interest rate, okay, when do I need to use annual effective interest rate? When can I use the nominal interest rate at its face value? When do I have to divide the given interest rate by the number of compounding periods and then use that in the problem statement? You will be golden. Okay. And if you have a wishy-washy understanding of interest rate, you're not going to go far, because interest rate forms the foundation of all the calculations, whether you're dealing with the time value of money, whether you're dealing with the cash flow diagrams, whether you're dealing with inflation, okay, cost benefit analysis, bonds, even taxation. Interest rate, the concept of it's basically the glue that connects everything. So I cannot overemphasize, and that's why within the on-demand content, you're going to see the very first lecture that I have is about interest rates. Several practice problems, in-lecture practice problems to help you work through interest rate. And don't overlook engineering economics just because it's a simple line item, right? It is still a very important topic. We know in real world, as I was commenting earlier, it's basically the dollars and the cents as much as anything else that drive our decision making process, right? Even in a technical field like engineering. Okay, so this is a quick summary strategic review of the topics that you see on the screen. In my opinion, these topics are actually low-hanging fruits within the context of PE power. It doesn't mean that you should not pay attention to them and you are guaranteed to score points on them. You will still have to pay a lot of attention to them. Aim for level 3 understanding, where you have the conceptual understanding, where you can translate the formulas into, visualize them, and are able to handle the UOM, units of measurement, properly, and you're able to make the distinction between some of the subtle and the nuanced concepts related to these knowledge areas. Okay. And for additional practice, definitely go through the on-demand lectures, quizzes, in-lecture practice problems, mini exams, study guide problems, homework assignment, the live training recording, and I think you'll be set. If you like this video, then please don't forget to subscribe to this channel. Feel free to ask me any questions in the comment section of this video below. You can find tons of success stories of my FE Electrical and PE Power students over here. And if you want to learn more about preparation of FE Electrical and Computer exam and the PE Power exam, then check out these playlists over here. Thanks for watching, and I'll see you soon in the next video.